The following is a warning. The next few minutes can contain some content that might not be suitable for people who do not enjoy nerd town stuff, such as science, because it's just going to be me talking about science because Nama wanted me to talk about science. And, well, she commanded me. I have to obey. So, if you're not ready for this, run in fear. Alright, woman, you also suggested this. Well, not suggested, you requested this. Requested is the proper word. You requested to see what I was doing yesterday. Well, here's what I wasn't doing yesterday. So doing today, I was teaching kids quantum mechanics. Yay, wave functions, yay! And then that's fancy formalism. That way I don't have to write out all the integrals like that. That's a double integral over two absolute values like functions squared. Messy craziness, but it turns into those cute little things. And then you get answers down there. But anyways, that is what I was doing today. And then yesterday I was working on the code. And this is helping me figure it out. The correlation function at diagonals for interlaced, like, lattices. Yes. And here, that's some ideas for code that I was doing. Blah, 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 blah. More stuff. And that's an OR symbol. That's an AND symbol. So I'm doing this weird complicated thing of AB or BA or AB, AA and BB. Yes. What does that mean? Here's trying to figure out the correlation function, but only calculating the change in correlation function. So that way I don't have to keep on calculating the entire thing, because that takes so long for the computer to figure out how correlated it is with itself. Ugly. It's nice just to do the small incremental changes. Here I was doing the general layout of my program. I was doing it in C, so define, if you can read my writing, is very handy because I just want to make things very simple. I was realizing things as I was going along and just writing them in. Going along, started doing the actual program. The entire program relies on this one thing right there. Random. All about predicting things with random numbers. I absolutely love that. All random numbers. It's not calculating some exact value, it's just like, random numbers. Look, here's the answer. Energies, temperatures, blah blah blah. Trying to figure out schematics of things, how things would work, using moduluses. That's the modulus right there. You think it's percent sign. Well, it is. Oh, that's horribly out of focus. Oh, yes. Hey, there's equal to. Well, not like saying something is like, is it equal to? Yeah, that's part of the code right there. It's figuring out. There's helping me figure things out more. And here, this is me showing how these sites on the lattice interact and how I have to figure out the this is how, like, you have to go +1 in the y direction and +1 in the x direction and -1 in the y direction and -1 in the x direction. But then for other fancier stuff I need that, and then I need that. And I was trying to figure out how to do that. And here's the energy of things. I have to minus off that. It's all very ugly. So, just continue to work on that. Alright, Nama. Yes, that's woman's name. I recently found out I have permission to say her name on YouTube. I thought she just had an N for her name on YouTube, so I was like, I don't want to violate her privacy. But then she changed it to Nama. So, I can say her name, Nama. Well, this is the screenshot of the actual code that I'm working on right now. So yes, Nama, you get to see it, and it's all fun-like, and my favorite parts are the pound if statements, which don't seem that cute to anyone besides me, but that's okay. It's just very helpful for making the program not so bulky when I adjust the parameters, so that way AA does equal 0. Then it doesn't even include that line of code when I compile the program. Very helpful. What this code is going to be doing is approximating a solid through many bodies. So this is only two-dimensional, so it would be only useful for like sheets of materials. But this isn't. This is just an undergraduate student just doing stuff, not like, oh, industry. I'm making an airplane out of bullets. It's like the ultimate recycling genius job ever. No, it's not like that at all. Yeah, it's just computer programming. Yee! And I'm putting this on a PS3 cluster, and I'm gonna have a link right now. Woo, woo, woo! And it's gonna let you click on and see what in the world is a PS3 cluster. And I'm going to be trying to not show, um, yeah, anyways, I have a picture up right now of what an example computation might look like, and that's not actually what I want, that's just kind of a way to visualize what I'm doing. Want are these like thermodynamic properties of this picture, and this picture is constantly changing and moving around. All the black dots represent magnetized up, and all the white dots represent magnetized down. It's this one big hulky material. Think of iron. And there's a fancy temperature I'm trying to find called the Curie temperature. You can look it up on Wikipedia. And that's when things become spontaneously magnetized or spontaneously unmagnetized, depending which direction you're going on the temperature scale. So yeah, that's the project I'm doing. And it's fun.
Yes.